Download this code from codegive.com, link in the description below. C++ concurrency, exceptions and async/await, a deep dive. This tutorial explores exception handling and asynchronous operations using async/await in C++ concurrency, focusing on practical examples and best practices. We'll examine 12 common exception scenarios, illustrating how to handle them effectively within asynchronous contexts. Note that true async/await requires C++ 20 coroutines, and its behavior varies slightly depending on the library used, like boost.coroutine or a compiler's built-in support. This tutorial aims for a general approach applicable across different implementations. 1. Introduction to C++ concurrency. Modern C++ offers powerful tools for concurrent programming, allowing you to leverage multi-core processors and improve application performance. Key elements include *threads, *independent execution flows within a process, *futures/promises, *mechanisms for asynchronous communication between threads, *atomic operations, operations that are guaranteed to be indivisible, *mutexes/semaphores, synchronization primitives to prevent race conditions, *std async and std future, high-level abstractions for asynchronous task execution. These are crucial for our async/await exploration. *coroutines, C++ 20 and later, enable writing asynchronous code that looks and behaves like synchronous code, simplifying complex concurrent scenarios. 2. Exception handling in concurrency. Exceptions thrown in one thread can disrupt the entire application if not handled properly. In concurrent scenarios, this requires careful consideration. *exception propagation, exceptions thrown in a worker thread must be handled in the main thread or a designated handler. *future/promise interaction, exceptions thrown within a task launched using std async are stored in the associated std future. *synchronization, exception handling must be carefully synchronized to avoid deadlocks or data corruption. 3. std async and std future fundamentals. Before diving into async/await, let's review the building blocks. This showcases std async launching my function asynchronously and std future get, retrieving the result, handling the std runtime_error. 4. Introducing async/await, C++ 20 and later. Async/await significantly simplifies asynchronous programming by making it resemble synchronous code. A function marked with co_await suspends its execution until a future is ready, automatically resuming when the future is completed, or an exception occurs. 5. 12 exception scenarios and handling with async/await, conceptual. To fully illustrate this, we'll need to use a coroutine library, like boost.coroutine 2 or a compiler with sufficient coroutine support. For clarity, this section presents the conceptual code and exception scenarios. Adapting to a specific coroutine library involves understanding that library's specific mechanisms for awaiting futures and handling exceptions. Note *, the following examples represent the conceptual structure. The precise syntax for awaiting and exception handling will be library specific. 12 exception scenarios, adapt to your coroutine framework. 1 network error * fetched data, throws std runtime_error. 2 file IO error * similar to network error, but during file reading/writing. 3 database error * exception thrown by a database interaction. 4 invalid argument * processed data, throws std invalid_argument. 5 out of memory * std bad_alloc during memory allocation. 6. Timeout * exception simulating timeout in a long-running operation. 7. Cancellation * exception representing task cancellation. 8. Concurrency issues * exceptions related to race conditions or deadlocks. 9. Arithmetic error * std overflow _error, std underflow _error or std domain _error during calculations. 10. Type error * std bad _cast during type conversion. 11. Custom exception * user-defined exception for application-specific errors. 12. Exception during await * exception thrown in the future being awaited. 6. Best practices for exception handling in async/await. * structured exception handling * use try, catch blocks to handle exceptions appropriately. Specific exception types * catch specific exceptions instead of relying on generic catch. Error codes for asynchronous operations, consider returning error codes or status objects alongside results. Logging log exceptions to assist in debugging and monitoring. Recovery if possible, implement graceful recovery mechanisms instead of just terminating. Testing thoroughly test your asynchronous code with various exception scenarios. 7. Conclusion. Exception handling in C++ asynchronous programming is crucial for robustness and reliability. By carefully integrating exception handling with async/await and coroutines, using a suitable library, you can create efficient and fault-tolerant concurrent applications. Remember that the precise syntax will depend on your chosen coroutine library. The conceptual examples provided here guide you toward implementing proper exception handling within your chosen framework. Always refer to the library's documentation for the most accurate and up-to-date details.